Okay, for example 4, same basic idea here. We have a polynomial function here, p of x, 2x cubed minus 8x squared plus 9x minus 9. Again, this is not something that has a common factor I can pull out. It's not easily factored in its current state. Cubic functions are not easy to factor unless you just happen to know something, such as a root. So if x equals 3 is a root, that means x minus 3 is a factor. Again, let the root establish the factor. Whatever the root is, x minus that number is the factor. I'm going to divide my polynomial p of x by my factor, so I'm going to put 3 up in the box, and over here I'm going to put the coefficients of my cubic function, positive 2x cubed minus 8x squared, positive 9x, and then minus 9. Again, every power of x has been accounted for, no zeros are necessary, x cubed, x squared, x constant. Got the whole thing here. Again, if it's negative, make sure it's minus. If it's negative, make sure it's minus. If it's positive, it can be positive. All right? And once you get everything set up here, step 1, bring that number straight down. Whatever that number is comes down. It's not this number, it's that number. And on homework, a couple of you were trying to put that number down there.
Mr. Klein,
Yes?
your 3 would be negative.
No, it'd be positive.
Why?
Divided by x minus 3, I'm going to change the sign.
Oh, I was looking. Never mind.
All right, so again, if you know what the root is, that's what goes here. If you're identifying the factor, you change the sign in the factor.
How do you know if it's always x minus 3?
If it's x equals number, you write the number. If it's x minus 3, you change the sign.
Okay.
If it's a binomial, change the sign. If it's not a binomial, just write the number.
I didn't know, like why is x equal 3 always negative? Is it
If x equals 3 is a root, that means that x equals 3, which means x minus 3 equals 0.
Okay.
Right, so basically we're going, if we had this factor, we'd go to that to
Okay.
solve it, right? So if we have the solution, we go backwards to get the factor. Right, so whatever they're giving us as a root, x minus that number is the factor. If we're dividing by x minus 3, we're going to put a positive 3 here. All right, so 2 comes down, 3 times 2 is 6. Different sign, subtract, 8 is bigger than negative. 3 times negative 2 is negative 6. Different sign, subtract, 9 is bigger, positive. 3 times 3 is 9. Negative 9 plus 9 makes 0. Remainder of 0 is what we expected. Okay, so we're good to go there. The reduced polynomial is 2x squared minus 2x plus 3. So p of x equals our factor, which is x minus 3, multiplied by our quotient, 2x squared minus 2x plus 3. Again, the quotient came from right here. We divided this polynomial p of x by this factor x minus 3 to get this 2x squared minus 2x plus 3, remainder 0. Once again, we have a linear factor times a quadratic factor. Once again, the quadratic factor looks not easily factored, right? This time it has a 2 in front of the x squared, which makes it even more challenging. So for my personal interest here, if it's me and I'm doing these problems, and I got a number in front of my x squared like that, I'm just going to go ahead and go quadratic formula every time. Once it's quadratic, the quadratic formula always works. Never ever fails. Even when the answers are nice and pretty like 2 and 3, it works. When the answers are 1/2 and 5, that works. When the answers are negative 3 plus or minus the square root of 3, I over 2, it works. So it always works. It's useful. A equals 2, B equals negative 2, C equals 3 for this right here. So if I'm looking at b squared minus 4ac, again, it's very, very important that you pay attention to detail. This object, no matter what b's value is positive every single time. When you square a number, sign irrelevant of the number you're putting in there. If you square any number that's a real number, its square is going to be positive. So negative 2 squared is positive 4. Minus 4 times a times c, which makes 4, and then I do the product next. 4 times 2 is 8 times 3 is 24. 1 minus makes it minus 24. 4 minus 24 is negative 20. Carry out the operations correctly. Evaluate everything correctly. Follow the order of operations correctly. Pay attention to detail all the way through the process. Okay? Then, for the green part here, I'm going to go green pen. X equals, I go ahead and create my quadratic formula structure. Negative 20 goes inside the radical. Minus b is change the sign, positive 2. 2a, double a, 2 times 2 is 4. Okay. This particular thing does reduce and simplify, so I expect you to reduce and simplify as much as humanly possible. Take a look at the square root of negative 20. First off, it's I times the square root of 20, right? If nothing else, at least pull the I out of it. Does 20 break down to what?
5.
5 times what?
Negative 5, right?
20. 5 times what?
4.
5 times 4, and 4 is? 4 is what times what?
2.
2 times 2, right? So when you're looking at a number inside a radical, if the number itself factors down, and in the process factoring down to all prime factors, we happen to get a pair of numbers in the object, we get to pull a square root of that out. 2 times 2 is 4, the square root of 4 is 2. 5 does not have a square root, it stays in. So the square root of negative 20 simplified is 2i times the square root of 5, so I get 2 plus or minus 2i times the square root of 5 over 4. Okay. And at this point that might be done, or there might be more we can do to it. Notice that we have term 1 plus or minus term 2 divided by term 3. There's 3 terms in that. Look at the numbers outside the radical. If the same number divides all 3 numbers, it's legal and expected to reduce by that number. So notice all those numbers divide by 2. I don't care about inside the square root, I care about outside the square root. So 2 divided by 2 is 1, 2 divided by 2 is 1, 4 divided by 2 is 2, everything divides by 2 evenly. So the best final answer for this is going to be x equals positive 1 plus or minus the square, I times the square root of 5 over 2. Okay. Now, typically when I take something out, when I divide by it and I get 1, I don't write it down. 1 plus 1 minus, the 1 matters. 1 times doesn't matter. So if I got to do 1 times x, that's just x. But if I have to do 1 plus x or 1 minus x, that 1 does matter. So in this case, 2 divided by 2 makes 1. I'm doing 1 plus something and minus something. This 1 matters. The 1 here is being multiplied by I. That 1 doesn't matter. I typically don't write ones that don't matter. I typically write the ones that do matter. If you're not sure at this point, write down 1 every single time. It's not wrong to put it, but it's wrong to leave it off sometimes. So if you're unsure, when am I supposed to do it, when am I not supposed to do it, put it every single time. Should this one be here? I don't know. Put it anyway. Should this one be here? Definitely not. Then don't put it. Should it be there? Absolutely. Then absolutely put it. And if you don't know the answer to that question, just put it every time. You'll never be wrong. If you're supposed to put it or you're not supposed to put it, you do put it. All right. It said find the remaining zeros. So they already told me x equals 3, but the other 0, x minus 3 equals 0, so x equals 3. But again, the remaining zeros will be these 2. All right. Zeros, root, solutions, that means the same thing. All right. So 4 problems are going to be like the first 2 where you have to either factor or it's already factored, set each factor equal to 0. The other 4 problems are going to be more like this where they give you a very difficult to factor expression, but they'll give you a root so you can use that polynomial division. Going back to Alicia's problem here, what if you put the wrong sign here? If you put the wrong sign here, you're going to get 0. If you don't get 0, you probably did the wrong sign. Go back and fix your work. All right? But for now, I mean, that's a fix. But again, if they tell you x equals number, that's the number that goes there. Or you can establish that's what the root would look like. That step right there is useful because what we're going to be doing tomorrow. So I'd recommend doing that, identifying from the answer what the factor is. And then if I'm dividing by x binomial structure, x minus 3, the rule says change the sign. Change the sign here to make the factor, change it back to do the synthetic division.